Wow, what a beautiful iris flower we have here. I think this iris belongs to species Iris setosa, or maybe it's Iris virginica, or maybe something else. I have its sepal and petal length and width as you can see here, but I can't figure out which species it belongs to. So what can we do about it? Generally we have to go to a specialist who then figure out the species of this flower. But today we are going to replace a human with a program. So how about making a machine learning model that can tell the species of iris flower? Sounds fun, right? But wait, I don't have my computer, it's malfunctioning. All I have is my mobile phone. Hello Pythonists, it's Tish and today I'm going to show you how to make a machine learning model in your mobile using the browser. So let's get started. So in this video, we are going to classify the species of iris flower. It means that we are going to code our machine to learn and answer which species of iris flower is the current iris flower belongs to. I have some past data about the iris flower. So let's talk about the dataset that we have here. It's a small dataset with 150 observations with 6 variables. Its variables are its ID, its sepal length in centimeter, its sepal width in centimeter, its petal length in centimeter, and its petal width in centimeter, and last, its species. See, species is the target variable which we have to classify here. Now, how we are going to do that? First, we have to install and import the libraries like pandas, numpy, and scikit-learn, and many more. Then, we have to set the environment variables, then we have to create virtual environments, and then we have to write 100 of lines of code. I'm just kidding with you guys. As the video title says, we are going to build a machine learning model in our mobile without using our computers and without handling these tasks on our own. All we gotta do is just write 9 lines of codes. So, in any machine learning model making, there are 4 simple steps. First, we have to collect the data that we have here as a CSV file. Second, we have to pick the model, or we can say we have to build the model, and then we have to train the model on the past data, and at last we have to test the model to see the accuracy of our model, to check how good our model predictions are. But how we are going to do this without a computer? So for this, first, say thanks to Google because of its colab research, which is obviously free for us. Now we have done that, moving on. So we are going to do it using Google Colab. Google introduced its Colab for deep learning programming and machine learning programming using GPUs. Actually, it uses browser's GPU to make computation efficiently and at fast rate. So to do that, all we need is a browser and a mind, of course, and a Google account too. So let's just minimize this and open Chrome browser. In the Chrome browser, tap this search box and type colab.research.google.com and hit enter. Let me just open it in desktop mode, so let me just click here. So it is loading. So go to the file and click on it, and then we have to select the new Python 3 notebook. You can also code on Python 2 as well, but who uses Python 2? I mean, some guys do, but we're gonna stick with Python 3 because it's the latest version of Python we have here. So just click on this new Python 3 notebook. Let me just open it in desktop mode, so let me just click here. Let it load. It is still loading. By the time it loads, let me tell you one thing, that this Google Colab project uses our browser's GPU for the computations of the programs. Yes, it loaded. Now, as you can see, the interface is much alike as the Jupyter Notebook's interface. It provides us a unique cell programming technique. This cell programming technique provides us a cell or multiple code cells within a document for writing and executing the Python codes. So let me just show you how you can add extra cell in a document. So let me just click on this code button here. So as you can see, one extra code cell is added in our document. So Before programming, we have to connect this document to Google Python 3 backend engine. So to do this, let me just click here, connect button. So it says it's connecting to Python 3 Google Compute Engine backend. So let it connect. So it says initializing. Yes, it's connected. So we are good to go. So now we are here. Let's do some machine learning programming. So for this, first we have to import two main libraries, and that is scikit-learn for machine learning operations and pandas for performing data frame operations. So let me just import panda here. So just type import pandas as pd and then go to the next line, and in the next line we have to import our machine learning algorithm. But before doing this, one question arises in our mind, that which machine learning algorithm should we choose for this problem? I mean, there are hundreds of machine learning algorithms are out there, like decision tree, random forest, XGBoost, linear regression, logistic regression, etc. Since we have labeled dataset, so we are going to use supervised machine learning algorithm, and we already know that this is a classification problem, right? Hence, we use a classifier, and we are going to use a famous machine learning model, that is a decision tree classifier. So to import decision tree classifier, type here from sklearn. Sklearn is a scikit-learn library dot tree. Tree is a module inside sklearn library. So from tree module we have to import decision tree classifier, and then go to the next line, and in the next line we have to import train test split method of model selection module. This method is used for splitting the data set of iris flower into two parts, one for training the model and second for testing the model. So to import this, first we have to write from sklearn, which is again our scikit-learn library, dot model selection. Model selection is a module, model selection, and from this module we have to import our method, that is train underscore test underscore split method. Now to run this cell, all we have to do is to click this black button here. So let me just click on it. So it's executing. Yes, it executed properly since we haven't got any error. So move to the next cell. So in this cell we are going to read our CSV file. So to do that, just type data equals to, data is going to be our variable in which we store our entire data set of iris flowers. So data equals to pd. Pd is our pandas library. So pd dot, then we are going to call a method called read underscore csv. Read underscore csv is a method through which we read our CSV files. So inside the parenthesis we have to provide a link to a CSV file. I already copied it to my clipboard, so let me just paste it here. So paste. Remember, the link should be in double quotes. So and then close the parenthesis, and then you have to execute the code. So let me just click on it and then execute it properly. So now to add extra cell, now just let me click here. So move to the third cell and type x equals to data, which is our variable. So data dot values, and inside the square bracket type colon comma 0 colon 5 and close the square bracket. Now move to the next line and type y equals to data dot values, and inside the square bracket type colon comma 5 and close the square bracket. Now execute this shell. Now here the x variable holds the data without target variable. That means it holds the value of variable id, sepal length, sepal width, petal length, petal width, and y variable holds target variable data, which is species in this case. So it executed properly. Now let me just add one extra cell. So move to the next cell, and in the fourth cell type x underscore train comma y underscore comma x underscore test comma y underscore train comma y underscore test equals to, and then we are going to call a method which we imported. So we are going to call train underscore test underscore split method, and inside the parentheses we have to give three parameters. One is x, the second one is going to be y, and the third parameter will be test underscore size equals to 0.3. Now close the parenthesis. Now the test size equal to 3 means that we are splitting our data set in 70 and 30%. 70% for the training the model and 30% for testing the model. Now click on this button to execute this code. So it is executing. Yes, it executed properly. Now let me just add one extra cell here. So move to the next cell, and in this cell we are going to make our machine learning classifier. So hence we already picked our model. Moving on to the coding part. So type here classifier equals to decision tree classifier, and inside the parentheses we have to provide just one parameter, that is criterion. So type criterion equals to, and then we have to provide the value of this parameter. The value will be in double quotes, so the value is Gini. Then we have to close the parentheses and then move to the next line, and in the next line we are going to call our classifier dot fit. So classifier is our decision tree classifier here, which we are going to use to predict our future data, and fit is the method which trains our model with the past data of iris flower. So fit, and inside the parentheses we have to provide two parameters. One is the training data without target variable, that is x underscore train, and other is target training data, that is y underscore train. So let me just type here x underscore train comma y underscore train, and then close the parenthesis, and then we have to execute this shell. So yes, it's executed properly. That's it, done. We just built our model in just 9 lines of code. Our classifier is ready to predict the future data of iris flower. So now we can predict the output of the test dataset by using the predict method. So to predict the future data, let me just add one more cell. Yes, now we have made our classifier. We can predict the future data. So to predict the new future data, type y underscore predict equals to, then we are going to call our classifier here classifier dot predict. Predict is the method which are used to predict the future data of iris flower dataset. So inside the parentheses we have to provide just one parameter, that is going to be the testing data for the model. So it's going to be x underscore test, and then we have to close the parentheses. Remember, y underscore predict is the variable which is going to store all the predicted value of our classifier. So let me just execute this cell. Yes, it's executed properly. Now we have made the model and predicted the test data, but we don't know how good our model is. So we need to check the accuracy of our model, right? Now to do this, we are going to use accuracy score method of matrix library. So to do that, move to the next cell. So let me just add one extra cell here. So move to the next cell and type. So first we have to import the accuracy score method. So to import, type from sklearn, which is our scikit-learn library. So sklearn.matrix. Matrix is the module inside the library. So from matrix module, we have to import accuracy underscore score method, and then move to the next line. So in the next line, type accuracy underscore score, and inside the parenthesis we have to provide two parameters. One is the testing data and other is the predicted data of our classifier. So let me just type here y underscore test comma y underscore predict, and then close the parenthesis, and then we have to multiply it by 100. We multiplied it by 100 to get the results in term of percentage. So let me just execute this cell and see the results. So yes, wow, and here is the accuracy of our model, and it is 100%, which is quite fantastic. I mean, it's quite impressive. We get 100% accuracy rate. Now you know how to build the model to classify the iris flower in your mobile. If you know the petal and sepal length and width, then you can easily find out the species of iris flower. Let me just show you how the model predicted the species of iris flower. Let me just add one more cell here. Then in the next cell, type classifier, which is our decision tree classifier dot predict, and then we have to provide the future data. So inside this double square brackets, we have to type 152 comma 3 comma 4 comma 3. And then we have to close the square brackets, and then we have to close the parenthesis, and then execute this cell. And as you can see here, the result is iris virginica. So we can say that if ID is 152 and the sepal length is 3 cm and the sepal width is 4 cm and the petal length is 4 cm and the petal width is 2 cm, then the flower will be iris virginica. So that's it for this video. If you found this video helpful, please like, subscribe and share it. Thank you guys.